Hello Gators, this is Exponential Functions. We'll be taking a look at exponential functions, growth and decay, and rules of exponents. An exponential function has a characteristic, it's a times b to the x power, not a power function like x to the second or x to the third. The x is now the exponent instead of the base. Let's take a look at the characteristic of the shapes. Very interesting shape. And notice where it crosses the y-axis, notice that it does not cross the x-axis. The rate of change is not constant because the ratios are not the same. Let's take a look at the comparison, some of the characteristics again a little bit more closely. The graph does not cross the x-axis. And when b, the base right here, if it's greater than 0, it's an increasing function. If the b, this number here, is a number between 0 and 1, it's a decreasing function. We call it decay. The domain is all real numbers. The range is positive real numbers. It doesn't get to be 0. It passes the vertical line test, so it's a function. And it passes the horizontal line test, which means it has an inverse. It has an asymptote, which is the x-axis. It gets very close to the x-axis, but does not touch it. Let's take a look at some transformations. Multiplying the exponential will compress or shrink. It will stretch if a is greater than 1, and it'll shrink if a is between 0 and 1. If a happens to be less than 1, then it's a reflection over the x-axis. Any shifts to the right or left are acting on x. Any shifts up or down are acting on the whole exponent right there. The intercepts, it's very important that we understand this is always true about the parent. It always passes through 0, 1. Because anything to the 0 power will be 1 as your output, and it has no x-intercept. Make sure you realize that. All right, and here is f of x equals a to the x. In particular, it's 2 to the x. 2 to the x, notice what it looks like. It's an increasing function. 2 to the negative x. Remember that this is the same thing as 2 to the negative 1 to the x power. That's where we get the negative x. And remember, 2 to the negative 1 is 1/2. So this is the decay. I hope you recognize the decay. So when we see the x changing sign, it means that it's now a decay function. It'll be going opposite direction. Changing the sign of the x means that the graph reflects across the y-axis. Let's take a look at this and see if we can operate on all of those transformations. So the parent is this. This is the parent right here. And we notice that the 2 is going to stretch it, and the negative 4 is going to change the asymptote because the whole graph goes down. Normally, the asymptote is located right here at the x-axis. And this means that we are bringing it down, so it'll be right here, down 4. And we want to state the domain and range. So the domain is all real numbers. And the range now, because the graph has transformed, will be from negative 4 to infinity. So there has been a change. All right, here are the rules for exponents. Number 1, number 2, number 3, number 4, and number 5. All right, I'd like you to stop the screencast and see if you can answer these questions. And here are the answers. Now, when we have these fraction forms, you can actually split up this fraction because a power to a power means you're multiplying them, so you can separate them. And it might be easier to do 27 to the 1/3 power, which is just a cube root. And then after you find the cube root, you can take it to the 4th power. And this thing is dead giveaway. Whatever this is has to be 1. And here we're using a lot of our exponential rules. So I decided to simplify the numerator then I decided to simplify inside the parentheses, and then I squared the whole thing. I'd like to get to the same base. Once I get into the same base, then I can simplify things here. And when you're solving, again, the idea is to get the same base. Once you get the same base, then here the bases are the same, then I can set my exponents equal to each other. Let's take a look at base E. And base E is called the natural base. And it's the most common base in calculus. We use it a lot. Base E is easier to do a lot of our calculus. And so by definition, this is the definition of E. And here it is to 3 decimal places. So remember, this is bigger than 1, and it's bigger than 1. This is a growth. We know that one of the characteristics is all exponentials have 0, 1 as one of their points, and we know another characteristic is that it's an increasing function. So it goes something like this. And if you want to write yourself a t-chart, you can. So we could have -1, 0, 1. And remember, 0 is 1. And then if you put a 1 here, that'll be an E. And you put a -1 here, this will be E to the -1, which means 1 over E. Now E, remember, is approximately 3. So this is about 1/3, and this is about 3. Okay, so can we make the adjustments and graph this? Well, remember the parent is E, but this is the E to the -x, which means there's been a reflection. So now we want to go as a decay, but also there's been an asymptotic change in that we are going to be going up 1. So no longer is it going to be at the x-axis, it's going to be at y equal to 1. And everything has gone up. Remember, normally the y-intercept would be at 0, 1, and it goes up 1 here, and then the graph will be a decaying function like this.